Hi, today I will present my final year project. My project is a CCD-based authenticity testing system for Gemstone. My name is Anis bin Abdul Razak and my supervisor is Dr. Juliza binti Jamaluddin. Some introduction. Gemstone valued by a rich are worth a lot of money and can be sold by millions in a bit, even though they are don't have everyday use. They represent wealth. A different kind of such as ruby, emerald, quartz, diamond, and sapphire have different values based on their quality. But technology have made fake gems, leading to fraud, scam, and money loss. Industry is looking for solutions that meet the needs of the gemstone evaluation technology that is portable, affordable, and work well. It's important to find a balance between being easy to use, effective, and convenient. This is crucial for both experienced collector and beginner in the world of precious stone. Currently, jewelry shops heavily rely on the expertise of their staff, as sending gemstone to a lab can be time-consuming and expensive. This study aimed to design a authenticity testing system for gems using a CCD sensor. CCD is charge coupled device. The analysis of the light intensity retrieved by the CCD sensor will determine the transparency of the gem. Proceed with objective. The first one is to investigate the capability of the ILS551A CCD sensor to capture laser from the range 450 nanometer to 650 nanometer wavelength. The second one is to design a gemstone inspection system with Arduino. And the last one is to evaluate the 3D hardware using various grade and type of gemstone. Now we go on a little bit of previous research and paper. Based on research and report from Gemological Institute of America, imitation ruby, for example, is made from glass and plastic. Thus, its reflection index is around 1.4. Color and no flaws. But real ruby have 1.76 reflection index and it have flaws. Next, go on current technology. Industry already have handheld spectrometer, UV vis and IR spectroscopy, high resolution photography, and ICP-MS. Most of them only can be found in laboratory and really depend on experience. The size also huge and expensive that makes a beginner or small leisure shop not having it. Here some picture of the devices. Lastly, we need to find suitable charge coupled device CCD sensor. There are a lot of type CCD we can find nowadays. However, for this project, I only need simple sensor that can detect object and cheap. Thus, linear CCD sensor is the best choice for me. Now, let's go to methodology for this project. First step, we need to supply two types of signals to CCD sensor, which is read out gate ROG signal and clock signal. Here is code for the signal. I use Arduino to supply those signals. Based on Sony datasheet, their linear CCD sensor, which is ILS551A, need two power source, 5V and 9V. They also provide schematic circuit. Then I design circuit using live wire and make printed circuit board, PCB. Lastly, I design boards for PCB and sensor. I use Tinkercad from Autodesk. I will show more about the design on demonstration part. Lastly, print the hardware using 3D printing. The final step is to evaluate the project using data from GIA and make classification and differentiation on the result for fake gemstone and the real one. Here I list costs for every component used in this project. CCD sensor from Sony, electronic component like a wire, and then Arduino Uno and cable, PCB, 9V battery, laser, and 3D printing. This is model for my project. The left one is when the box or the hardware is closed, and the right one is when the box is open. Let's take a look first. This orange is the laser. Now let's look a little bit closer. As we can see, this is a gemstone. This is a CCD sensor. We put the gemstone on the CCD sensor. Then we close the box and it's become like this. At back we have 9V batteries. This experiment need to conduct in low intensity of light to avoid the sensor saturated. That's why the box need to be closed before start the experiment. Then laser will be transmitted to CCD sensor. When the sensor senses light, the output voltage will become high, otherwise the output will be low. An easy way to explain this apply, real gemstone will have flaw because it is from geological event like earthquake and natural impurity. Thus the flaw will affect light penetration through the gemstone. Otherwise, the fake one is from plastic or glass, then light can easily penetrate the gems. That's how this system differentiates between the light and the fake gemstone. Then all data will be go through the MATLAB software to evaluate and validate the data. I think that's all from me. I hope you got something from this video, and thank you for watching.